Nucleophilic substitution. Tell me more about the synthesis of alkyl halides, esters, and amides through nucleophilic substitution reactions. Nucleophilic substitution reactions are a common way to synthesize alkyl halides, esters, and amides. These reactions involve the replacement of one nucleophile, an atom or group with a free pair of electrons, by another nucleophile in a chemical reaction. Alkyl halides are commonly synthesized by the nucleophilic substitution of a halogen atom, Cl, Br, I, on an alkane with another nucleophile, such as a hydroxide ion, O, or an alkoxide ion, or. This type of reaction is called an SN2 reaction, substitution, nucleophilic, bimolecular. The reaction proceeds through a transition state in which the nucleophile attacks the carbon atom bearing the halogen, while the halogen is leaving. The stereochemistry of the reaction depends on the configuration of the reactant. Esters can also be synthesized through nucleophilic substitution reactions. The reaction involves the reaction of a carboxylic acid with an alcohol in the presence of an acid catalyst, typically sulfuric acid or hydrochloric acid. The reaction proceeds through a tetrahedral intermediate and then through the elimination of water. The stereochemistry of the reaction depends on the configuration of the reactants. Amides can also be synthesized through nucleophilic substitution reactions. The reaction involves the reaction of a carboxylic acid with an amine in the presence of an acid catalyst. The reaction proceeds through a tetrahedral intermediate and then through the elimination of water. The stereochemistry of the reaction depends on the configuration of the reactants. Overall, nucleophilic substitution reactions are versatile reactions that can be used to synthesize a wide range of organic compounds, including alkyl halides, esters, and amides. These reactions are useful for organic synthesis because they are efficient, relatively simple, and can be used to synthesize a wide range of products with varying levels of complexity. Tell me more. Nucleophilic substitution reactions involve the attack of a nucleophile on an electrophilic center, leading to the formation of a new bond and the expulsion of a leaving group. The reaction can proceed through different mechanisms, including SN1, substitution, nucleophilic, unimolecular, and SN2, substitution, nucleophilic, bimolecular, mechanisms. The SN2 mechanism involves a one-step concerted reaction, where the nucleophile attacks the electrophilic center and the leaving group departs simultaneously. The SN1 mechanism involves a two-step reaction, where the leaving group first departs to form a carbocation intermediate, which is then attacked by the nucleophile. Alkyl halides are typically synthesized using SN2 reactions, as they typically react with strong nucleophiles in a one-step reaction. The reaction proceeds with inversion of stereochemistry, meaning that the nucleophile attacks the carbon center from the opposite side of the leaving group, leading to the formation of a new bond and the expulsion of the leaving group. The rate of the reaction depends on the concentration of the nucleophile and the substrate, as well as the nature of the leaving group. Esters and amides are typically synthesized using reactions involving carboxylic acids. These reactions proceed through an intermediate in which the carbonyl-carbon is attacked by the nucleophile, leading to the formation of a tetrahedral intermediate. This intermediate can then undergo a proton transfer and dehydration to yield the desired product. In the case of esters, the reaction can be catalyzed by an acid catalyst, while in the case of amides, the reaction typically requires a stronger acid catalyst. Overall, nucleophilic substitution reactions are important tools in organic synthesis, as they allow for the efficient and selective synthesis of a wide range of organic compounds. These reactions are widely used in the pharmaceutical, agrochemical, and materials industries, among others. Thanks for watching. Like and subscribe.